Okay, hello everybody, and in this video we're going to make a Rust web server. So I'm going to do it from scratch. I thought of making a video up so here anyway, so in this video I'm going to take a look at this guide and make a web server. And for any one of you who really hates light mode, I'm sorry, but I'm using light mode because it's easier for me to focus. Okay, so first of all we need to import. So why did I even remove this? So we need to import use standard net GCP listener. And if we take a look at if you highlight this, Emacs is supposed to show you the a bit of the documentation behind this, and it says a GCP socket listener listening for connections, so you can bind to socket to listen. So it says gives all this stuff. So now you need to write yourself. You need to get a listener for yourself, as it's shown here, to listen to the stuff basically. And I'm going to write it out myself because if I copy paste, I'm not gonna learn. So listener equals GCP listener bind to 127.0.0.1 and import. Unlike Rust, we do our own thing, and it returns. So if we go and highlight bind, it returns a IO, and it's a result. So as it is a result, you can either match it or just unwrap it, right? So now you need to do for stream in listener.incoming. So basically, then you need to it implements an iterator for every stream. So anyway, for stream in listener.incoming, so then we need we first need to unwrap it. So what is that? So stream. So what is the type of stream now? So its type is result of GCP stream or error. So we either get a GCP stream or we get an error. So we're not going to do any error handling now. So it's to let stream equals stream.unwrap. We're going to panic if we get an error, and we're gonna say connections established. So it's just a print statement. Just copy paste it. So now it should, okay, I'm not using it, but I don't care. So now we need to be able to go there and copy this and paste here, and connection was reset, and we can see here connection established. So pretty cool. I made my first web server today. So now we can listen for GCP contents and address. So it says that you send it to port and 77. Okay, it's port, and HTTP is normally accepted in like other ports. I guess it's HE and HE. I guess those are the ports for HTTP. Oh yeah, it says here HE, but here you need sudo privileges for that, it seems. And the bind function returns an error, as we said. And then incoming method, So what does incoming method do? So incoming method on TCP listener returns an iterator that gives us a sequence of streams, more specifically streams of type TCP stream. So what does this even mean? So it, oh yeah, we just get it. So using the incoming method, you just get the TCP stream. I don't know what the hell that is, but you get that. Okay, I don't know. This is why I like C so much, because it's when you're writing something in C, you're like actually implementing it bare bones, so you know exactly what's going on. In Rust, it's like abstracted away, but you can still go down, but it's still abstracted away. So anyway, this is what you need to give up for safety. So single line stream, okay, it's okay. So, one stream represents open connection, okay, between client and server. Connection is named for full request and response process, and so you use this connection to actually do different stuff. Let's say server generates response. Okay, we see. Or this for loop will process each connection in turn and process it. So what I want to know is basically this for loop is basically getting all the iterators, right? So if it is getting all the iterator, then iterator is like implemented in such a way that you in the end of the iterator, you probably go somewhere like in the end of the iterator, it's always I guess it is result and error. I guess this is what you get, and if it is error, then it is the last part of the iterator. You don't go beyond that. Iterator is over, and then but here, if you never get this, then a stream would oh yeah, I get it. So as long as you're not done with this stream right here, you basically don't go forward with the loop. But what happens when you're done with the stream? I don't know. I basically don't know. I don't know how it works, but it works. That's it. So we're going to learn more about this later on. For what clients say. So it says a single stream represents an open connection. So when the connection is over, then the loop will just continue again to get another connection, I guess. Okay. So in this way, this stream will last for like so long, it'll take too long for it to work, I guess. And then after that, connection established, and then basically it's dropped or something. So a connection is the name of full request and response process in a client when the server generates a response and server closes the connection. As such, we will read from TCP stream to see what the client sent, and then write our response to the stream to send data back to the client. Overall, this for loop will process each connection. So yeah, we process each connection. So for now, we're handling with unwrap. Okay, we'll add more functionality. Error from the when a client not actually it. Okay, the reason we might receive errors from the incoming method when a client connects to server is that we're not actually iterating over connections. Instead, we're iterating over connection attempts. So we are actually iterating over connection attempts, and if there's no proper connection, we'll get an error. Okay. The connection might not be successful for a number of reasons, many of them operating system specific. For example, many operating systems have a limited number of simultaneous open connections they can support. New connection attempts beyond that number will produce an error until some open connections are closed. Let's try running this code, and yeah, this is basically what happened. You'll see messages printed for one browser request. Probably it's sending more. It could also be that browser. Okay, there might be that the browser is making request per page as well as the request for other resource, and it could trying to connect to the server multiple times. When stream goes out of scope, it is dropped at the end of the loop. The connection is closed as a part of the drop implementation. Browsers sometimes deal with close connection by retrying because they think it's temporary. And remember to stop the program by pressing Ctrl C. Okay, we know this. I wonder what the Windows people do. So now you need to implement a bit more stuff to get your things done. So we're gonna do that. So we need net of TCP listener and TCP stream. So, don't we already get a TCP stream here? It's probably already in scope. Yeah, it's already in scope, but I don't know why. I don't care now anymore. So okay, and TCP stream, and then we need IO prelude, everything from there. Okay, we should do this, and then we need buff reader. So what does buff reader do? It's a struct, it seems. So these imports are pretty fine. So they are unused imports. So what does this actually do? The purpose of this module is to elevate imports of many IO common traits. Okay, so these are some IO common traits. Okay, buff reader adds buffering to any reader, so it can be excessively inefficient to work directly with read instance. For example, every call on read on TCP stream results in a system call. Okay, so every syscall takes more resources, so you just buffer it up and do large things all at once, making it really quick. So TCP listener and TCP stream. Okay, we get this. So now we actually handle connections by a connection handle. Handle connection. It says it is it takes a mutable stream which is of the type TCP stream, so this is all it takes, it seems. And so now we need a buff reader, so we are making a buffer to make it work really quickly. So buff reader, I guess new, and we basically take mutable reference to self, right? So is it self or stream? Oh shit, so I guess so Control C L R R, so renaming this here is a bit better. So now what? And then we need the HTTP request vector. Okay, HTTP request vector, which is a type vector of some, I don't know what this actually represents. So we need buffreader dot lines. So we're gonna send, so the map, so results dot unwrap, and then we are take while, so take while, so line, so line is not equal to, okay, line is not empty, probably empty dot, so then we collect everything and turn it into the good stuff. Now what does this basically do? So it is a vector of string, okay, and what is a buffreader? Is a buffreader of mutable TCP stream. Anyway, I don't care what this means. We can read what this means in here, as I use huge text. So we're just going to print line request. Okay, so HTTP request, okay, doesn't it, so I guess you so yeah, so this is it. So first let's read. So we bring preload and buffreader into scope to get access to threads and types that let us read from and write into stream. So you need these to read and write into stream. In the for loop, the main function, instead of printing a message, it says, so we now handle connection. Oh, I forgot here, we actually have to handle connection to stream. So here we go, and pass stream to it. If the handle connection function, we create new buffer instance that wraps mutable reference to stream.buffreader, edge by buffering stream buffer by buffering and by managing calls to standard IO read trait method for us. Create variable name HTTP request to collect the lines and requests of the browser sends to our server. We indicate that we want to collect these lines vector by adding the okay as vector. Buffreader implements standard IO buff read trait, which provides lines method. The lines method returns an iterator of result string or error by splitting the stream data whenever it sees new line byte. So it splits every time it sees a new line byte to get each string. When we map unwrap, the result might be an error if the data isn't valid UTF-8 or if it was a problem reading from the stream. Again, production problems should handle these. Okay, we must handle. Okay, the browser signals the end of an HTTP request by sending 2 new line characters in a row. So to get one request from stream, we take lines until we get line empty string. Once we collected the lines into vector, we're printing them out using debug so that we can take a look at the instructions. Okay, let's try this code. So we need to try this code. Is it running? So if we reload, okay, we get these things. So these are, I suppose, the TCP connections. So we're just removing all the users and new lines and stuff. It looks very much like JSON, I guess. Okay, so now okay, depending on your browser, you might get slightly different. Okay, it's looking at the get first line request. If okay, a closer look at HTTP request. So it says request line holds information about client, and getter post, whatever the hell that is, which describes how the client is making requests. Is slash, which indicates uniform resource identifier. URI client, yeah, requesting a URI is almost but not quite the same as uniform resource locator, URL. Okay, and the last part is HTTP version. Okay, the and then the request line ends in CRLF sequence. Carrier is written in line feed with okay, which are in terms of typewriter days. Can also be written as /r/n / carrier. So request line from rest of the request data, not that way, is printed. We see new line. Okay. So look at the request. Okay, remaining lines from host on okay, and then so writing a response, we're going to implement sending data in response to a client request. Responses have a following format. So it's HTTP version, status code, JSON phase, and headers and message body. So status code, okay, what about the hell? The first line status line contains HTTP version, and then summarizes the result of the request. The reason phase that provides text description of the status. Okay, here's an example response that HTTP version 1.1 has a status code of 200. An okay reason phase and no headers in the body. Is standard success response that takes is tiny successful HTTP response. Let's write this to the stream as our response to successful requests from the handle connection function. So remove print line and we write all. So why are we like buffering this? To get the result quickly, I guess. Oh yeah, we're buffering this to like get all the results all at once, and then seeing the data, and then for that we can't do it as some. So this is supposed to be format of a response. So just paste it up then, and stream dot write all buffer is dot as bytes dot unwrap. So why do we even have HTTP request at this moment? We don't need it, but let's just cargo run. Okay, if we go here and do this, we don't get an error, we get a response back, and the browser says okay, it's fine, we got a response. Okay, we're not getting any output, but yeah, we made connection and we got a response. Pretty cool, ain't it? So the first new line defines response variable. That holds success message data. Then we call sbyte to byte, write our method stream text LKU8 sends those byte directly down connection before, because the write-all operation could fail. So yeah, so in real life you would error handle with this changes. Let's run our Rust code to make a request printing any data to the terminal. So we won't see any output other than output from cargo. When you load, you should get blank page instead of you just had code receiving an HTTP request and sending. Okay, now we're trying to return a real HTML. So let's implement the functionality for returning more than a blank page. Create a new file, hello.html, in root of your project directory, not the source directory. You can input any HTML you want. So yeah, so we're just gonna use this, and then so hello.html. okay, it's HLLP. So we can paste it up basically. So kill this. So we can go eShell. So so we're done. So yeah, here we are. Now we just have to open up the file. So we probably need to import fs to work with files. Now you just need to open up the file, and so first of all you need to open up the file, right? So for that you need read to string. Okay, okay, so it literally gives the ownership. If it was C, it would give a pointer, but in Rust it literally gives the ownership here. So read to string, and it is hello.html dot, you might not be able to get it, so you just unwrap it. So and the length, okay, we need a status line. So this is so this should be on top, and we need a length. And after that we need a response, and response is pretty dope. I'm just gonna copy paste this thing because this seems really So this is response, and we should get this HTML. So we should get hello from Rust. Now let's see. With fs and use, so we're just using this to open up a file. We use format macro to format a string. Okay. So now after that, what we need is cargo run basically. So, and then we just reload this to get okay. We actually don't get to see it, unfortunately. Why? I don't know. We get the HTML, but it doesn't like compile it. It seems like what's the problem here? Okay, that means if you try requesting, must want to customize our responses depending on request. Only send back HTML file for well form request to slash. Validating the request and selectively responding. Right now our web server will return HTML. Okay, let's add functionality to check the browser is requesting slash before returning the, and return an error if the browser. Okay, I don't get it, because what happens if I like copy everything? Because it didn't work. The thing, you know what? I'm done. I'm just gonna copy everything, because we didn't get a proper HTML. So I'm just going to, of course, do this and just paste everything up, write it up, cargo run. So what happens if we run this again? Do we get a proper HTML this time? Well, we get a proper HTML this time. What am I missing here? God, I need to know what I'm missing here. So what should I do then? I don't know. Let's I really need to know the difference here, guys. Why? I guess I'm gonna uncomment all of them for now. Before, and then I'm just gonna put it down here like this one. So I'm just gonna Y, and then WL paste to, and then I'm gonna copy this. So what's the difference? Map. Okay, it's the status line. What's the difference here? I really don't see it. Okay. Okay. So the response is changed, it seems. So basically, if we like this and the response, if we go something like okay only, so this, right, and run again, we should be seeing hello. Yes, as I thought. It was like it had a problem here because our status line was quite different. That is why it didn't work. So we're done here. So now we're doing something else here. So HTTP request. Okay, so validating request and okay, error to the browser for we need to modify handle connection as 2.6. This new code checks the content of the request received against what we know, and request per slash looks like an adds if else block to treat request differently. So how does this work? So if request line, what is a request line then? So we're gonna change this a little bit. So we're gonna change the whole freaking function now, aren't we? So basically we need a request line. We don't need HTTP request now. Line equals, it is a buff reader, so we buffer it up to read all at once. So we first need to lines. What does this function do? Returns an iterator over the lines of this reader. So it returns an iterator over lines dot next. You get the next line. Wait, I will do this. I will print, so I'll just debug HTTP request. So after debugging, we can probably cargo run and request in here and see. Yes. Oh, so I basically get it. We're trying to get a this exact line, to get this exact line, what we're doing here in what they're doing here is we take the buffer reader, split it into lines. You get the next line, which is probably the first one, and that's second next will get you the second, and then and this could be true or false. So you unwrap it and you unwrap it again for some reason, I don't know why, but you could, if you did next twice, you would get probably this one, and if you did next twice again, you would probably get this one, just like that. So this is it. We get what this, or what we're actually doing. Then cancel this up, and then we can remove this debug. So request line, it's okay. I'm okay. It's buff reader. We convert it into an iterator, get the first line, and then unwrap. Okay, what and what is the type? So this type is result option of result of string. So you get an option, and when you unwrap it, you get option. So option is yes or none, and if you get yes, so if you get none, it's not working, and if you get yes, you get string or error if it is a stupid string. And I guess you basically this function returns a contains some value. So okay, I get it. You need to unwrap twice for some stupid reasons. Okay, some stupid programming reasons. And then request line, so we don't want anything to this thing to be different, because it depends, everything depends upon this thing being in correct manner, it seems. So now, so if there's an if statement to check, so if request line equals what is that? So I wish I had this Vim feature to copy everything here, but no. Paste. So if that's the case, so I guess what actually matters is just the format here. So we're gonna do this thing, say and else block. So in else block, we're going to send something different. So for that, we need a error request. So we need to give some error. So we're gonna send something. So this is 404 not found. We can just copy everything here. Okay, and just paste it down here. And so let contents fs read to string, and then 44.html dot unwrap. So if it doesn't exist, we're gonna go into trouble. So let length equals contents dot length, and we can probably just copy everything here. So okay, okay, we're just gonna paste it down here. So we get a response. We have two types, so we get a response, and then we just write the response. So pretty good. And then we now need the 404 HTML, obviously. So we're just going to the 404.html. Is that it? So just paste it up, kill this buffer, and we can probably, what's wrong here? Oh, okay. So pretty good. So what do we need now? So response. Okay. So it is a response. We need to define response before the scope, which is probably going to be it's just a string. Let response is string new. So it's probably got to do the trick. Oh god damn, so it needs to be a mutable. Okay, we solved it. I mean, it's red here, of course. We're not gonna run it here, okay? So if we reload, we should get Rust. If we go whatever the hell, we said, okay, we're getting an error here. Okay, pretty based, and here we get hello. So this is how it seems to work, and it wants a touch of refactoring. So I don't know how it was actually written here. Oh, so it writes the stream within the if else block, which would not require you to do any stupid stuff, but I wanted it to be separate because I'm quite claustrophobic. So and handle connection. So it's a so we are this guy's this is like basically pattern matching. So let status line file name if request. Okay, we're refactoring it in a proper way. So I like this. So we're going to do this again. So where are we here? Where's Emacs? Okay, here. So this is a proper refactor. So I like it. So what can we do? So we can just start writing here. So let, so there's a tuple. So first of all, we need file name and then status line, and then file name equals if the request line equals this stupid string here. So paste it. So we have if it is status line, then if it is that, then status line is going to be okay. What the so this is going to be the status line, and file name is going to be, of course, hello.html. It's a great refactoring technique. I love this refactoring. It's elegant. So here in this, so it is, so of course we get we need to get an error. So .html. So like I love this the fact that you don't need to write return in Rust, which makes these kinds of codes like a bit more elegant than other programming languages like C. So C, or I guess Python. I mean everything is so paste it up. We have a response, and then just need okay. So we need length. So and contents, which is going to be file name, of course, and then we can just so can we write this? So this is a, we don't need this. Okay. So yeah, now we don't get any errors, and I guess this refactoring like way better than what I did there. So yeah, it's readable and stuff. So I guess this is the kind of code those programmers who write haiku write. I don't know, self-explaining haiku write. So we're done. Cargo run. So we go here. So in root, no problem. We go somewhere else. It says oops, oopsie doopsie, and a bit of refactoring, and yes, we understand this refactoring very properly. So yeah, it's pretty amazing. If request is there, we just return a tuple, which makes it really cool. So I like this. So I guess our single threaded application is done. Now we need to move on from single threaded application to multi-threaded application, and this is I'm going to do that in the next video. I don't care what the hell goes in here, because I'm done programming the single threaded Rust web application. I don't know how long the video recording has been, probably an hour or so, or 40 minutes. I don't care. Thank you very much, guys. I'm on Fedora now. Anyway, so yes, we just made a web server in Rust, and I can do a multi-threading in Rust, and I can also make 3 data structure in Rust, as well as a loop what is that called, a uh, linked list in Rust, which makes me a better programmer in Rust than in C. So this basically made me a better programmer. Reading the Rust book, it taught me different ways of programming, and yeah, this is pretty cool. Now we are almost over, so this is now after, in the next video we are all going to build, reading the book together, the thing where we turn our single threaded server into multi-threaded server, where the real fun happens, where we're actually going to use, I guess, not monad, it's what was that called, a mutexes and channels to pass data through. And this is probably it. Thank you very much, have a great day, and I will see you later on in a next fun programming session, I guess, because I can't tell this to be a coding tutorial, because I actually don't know how to do this. We learned this together, and I guess we'll learn also turning our single threaded Rust and stuff. Okay, thank you very much, have a great day, and I'll see you later on.